Show here, and today I'm going to show you how to diagnose and replace an ignition switch on a 97 Honda Accord. Now the symptoms are the engine stalls out quietly, you could shift the transmission into park or neutral, restart the vehicle, it starts up just fine, and you're back on the road again until it stalls out again. Now what many people may suspect is the main relay, because the symptoms are slightly similar. Usually when the main relay fails, you have to wait a period of time for the vehicle to cool down before you can restart it. The reason being is because usually solder joints crack on the main relay. When the main relay heats up, the metal expands and the contact is broken. So you're not able to restart the car immediately. As the car cools, or as the solder joints cool more specifically, you're able to restart the car again. In the ignition switch situation, as I said before, you're able to restart immediately and get back on the road.
Alright, let's get started. The first thing I'm going to do is recreate the symptoms.
Now the best way to coax this problem out into the open is to put the key in the ignition, turn it to the 2 position so that your dash lights light up, hold the brake, shift yourself into any gear but park or neutral, be sure to hold the brake, make sure your parking brake's on, then turn the key and let it snap back from the start position. When you look right there, the dash lights have gone off. Now if I wiggle the key, I can actually get the lights to come back on. Turn it to the off position, I'll do it again. Turn it to the start position, let it snap back, and there goes the dash lights. Now the reason I'm putting the transmission in any gear but park or neutral is so when I turn it to the full start position, the engine doesn't start.
While this evidence points to a faulty ignition switch, I'm going to show you how to double check. We're going to run a continuity test on the switch itself. But before we do that, we are working on the electrical system, so be sure to disconnect your negative battery terminal and tuck it up to the side of the battery so it doesn't accidentally brush back into contact. Now we have to get to the fuse box on this 97 Accord. It's on the driver's side kick panel.
Here's your fuse box. Get that out of there. Get a light here. And you see that brown connector right up there? Right there. What you want to do is you want to squeeze that little clip there and just pull it out. Now here's our harness. This goes all the way up to the ignition switch, so we'll be able to do our continuity test from here.
Okay, before we begin, you'll need either a digital multimeter with a continuity function or a standalone continuity tester, which you can purchase from the big box stores for around $3 to $4. In this video, I'll be using my digital multimeter with the audible continuity buzzer. If you're using the standalone continuity tester, you're going to have to check that the light illuminates. If you do intend to use the standalone continuity tester, perform this little modification. Get a finishing nail. Be sure to sand it down with sandpaper or emery cloth to get any rust off it, which could affect contact, and just clip it on the end of the alligator lead there and it'll work just fine.
Over here you've got a wire. Black wire with a white stripe. This goes to your starter. This is a black wire with a yellow stripe. This is ignition 1. This goes to your main relay to send power to your ECU, fuel pump, fuel injectors. This wire here is white with a black stripe. This is your accessory wire. This is what sends power to low current drawing parts of your car, like your radio. That's what allows you to run your radio. Over here, you have this big fat white wire here. This is constant 12 volts from the battery. Now what this white wire does is, with the help of the ignition switch, it sends current from this wire to any one of these wires to activate different systems in the car. Over here, you got the ignition 2 wire, and this is a yellow wire. There's one thing that isn't going to change throughout these tests. One probe will always be on this solid white wire. As I said before, this is the constant 12 volt wire. The other probe will be on any one of these 4 wires. First thing we're going to do, as I said, is test the accessory position. The accessory position is the white wire with a black stripe. So we're going to be going from the white wire to the white wire with the black stripe. As you can see here, you got spade connectors, and there's that little loop in there. That's where you could put your probes in and they'll hold just fine. For our first test, I'm going to test the accessory position. I've connected one multimeter lead to the white wire, which is 12 volts from the battery, and I connected the other one to the white wire with the black stripe, which is the accessory position. Now I'm just going to turn my multimeter over here onto the continuity function. There we go. Now when I go to position 1, I should have continuity. And there it is. When I go to switch position 2, I should still have continuity. When I go to start, I shouldn't have continuity. When I release the switch, I should still have continuity. Next test, we're going to test ignition wire 1. One probe in the white wire, as usual, and the other one in the black wire with the yellow stripe. Alright, so I'm going to turn it to the 1 position. I should get continuity at the 2 position. Got continuity at the 2 position. Turn it to start, should still have continuity. Still have continuity. Now when I release it and it goes back to the 2 position, I should still have continuity. No continuity. If I jiggle it and turn it forward slightly, I can restore contact.
While this test proves that the ignition switch is electrically faulty, in an effort to be complete, I'm going to show you how to test the final wire, and that's the ignition 2 wire.
The ignition 2 wire is the solid yellow wire. So, one probe on the white, one probe on solid yellow. The switch should function as follows. Turn it to the 2 position, I have continuity. Turn it to the start position, I lose continuity. Let it snap back to 2, I should have continuity again. Continuity, lose continuity, don't have continuity. This ignition switch is faulty.
This is a little diagram showing the ignition harness pinout. This is with it facing you and the clip facing up. It also shows the ignition switch contact positions. This should work on 94 to 97 accords.
Alright, now we're going to have to get the steering column cover off. There are a total of 5 screws, 3 of them, that hold the column cover to the column itself are here, here, and down here. And then there are 2 screws that hold the bottom half of the cover to the top half, and those are one under the column adjusting lever here, and another one right under the lock cylinder right here. Just pull the adjustment lever down and just pull the covers apart. Top half comes off, the bottom half comes off. You slide it off the lever here. Make sure you just bring the lever down. Yeah, that goes.
The next step is to drop the cylinder assembly. While some of you may say, there's the ignition switch, and don't I just remove the screw there and it'll come right off? Unfortunately, no, because there's a 3rd screw that's hidden that can only be accessed by dropping the cylinder assembly.
In order to do that, we have to remove 2 bolts, and those are here and here. These are what are called shear bolts. As you can see, they have no head on them whatsoever. There's no way to grab them. There's a trick to get them off. First thing we're going to do is we're going to get this cable out of the way. As you can see, this goes to your turn signal. To get that out, simply squeeze this little tab here and pull that out. You're going to want to remove this harness here. Squeeze the clip, remove the connector. This goes to your windshield wiper switch.
Now here's the Achilles heel of Honda's shear bolt system. All you need is an awl and a hammer.
You just want to take your awl, put it on an angle, wrap on the back of it with a hammer to take those shear bolts right out. You're just spinning them out. As you can see, it's turning. Once you get them going, just keep doing that. Eventually they'll loosen up to the point where you'll be able to remove them. Still twisting that out. keep twisting until you can grab them by hand. You can see it's getting easier and easier. Alright, there we are. I'm loose enough right now. Should be able. Now the ignition switch is really loose. Should be able to just, there it is, come out by hand. And there it is. The ignition switch will just drop right out.
Now make sure you pick up an awl specifically for this job, because after you remove those shear bolts, the tip, as you can see here, is going to be completely wrecked. Okay, so we're just going to remove the two harnesses. That's the ignition switch harness. And that is the interlock harness for the key and that little LED. And that's it. Let's bring it to the bench and remove it.
Here's how it fits into the steering column. Fits up snug right here. Cap goes on top. Shear bolts go in. That is your steering wheel lock. If you turn your steering wheel more than a certain number of degrees, there's a slot cut into it. This pops up and immobilizes your steering wheel. Now there are two screws here and here, and this is why you had to remove this, because there's another screw right here. Okay, that's to prevent it from being removed without removing the lock cylinder. It's an anti-theft measure. So we're going to remove 1, 2, 3.
After all the screws are out, just pull it straight off.
Here's the part I got from Honda, part number 35130 SY8305. This is the ignition switch part number for the recall.
Honda released a TSB back in 2002, recalling ignition switches on a wide range of Honda models. Their explanation was the contacts burnt up, causing the switch to fail. Check in the description. I've listed the models and year ranges of the vehicles affected. If your vehicle is affected, you can obviously get the switch replaced for free if it hasn't been replaced before. If you want to do it yourself, I've listed the TSB number in the description. Get a copy of the TSB. It'll list what part number is for your vehicle. This is the updated part number. Do not order any other part number. Those are only for vehicles that haven't been recalled.
Now in this kit, you have new ignition switch, and this bag of goodies here. This is a new upper bracket, because if you did drill it out, most likely you'd screw this up, so they just include a new one.
What I mean by that is, the recommended service manual procedure is to drill the heads off the bolts. Just use the trick you saw earlier and you don't have to deal with that hassle.
And 2 new shear bolts. Now, as you can see here, this thing has a head on it, but it has a really thin stem joining this hex head to the rest of the bolt. What we're going to do is we tighten this, and then this head will twist off, and then you'd have what we had here. See, this is where the hex head used to be, right here, before it got sheared off. And then we have 2 screws. Those go on the rear of the ignition switch. We do not have another one of these screws. This goes on to the side harness here. Now this is only for the recall kit. If you buy the standard ignition switch that wasn't in the recall, most likely they will not include the bracket or the shear bolts or the screws. You just get the switch and you have to deal with everything else yourself. Now, you technically do not need to reuse these shear bolts. These are M8, 8 millimeters diameter, by 1.25, that's the thread pitch, by 14 millimeters long. Now what you could do is you could go get something called a cap screw. Now a cap screw, unlike a bolt, has a nice round head like this, but it has an Allen head on the top. And you may be able to find them in shorter lengths, and you may be able to use, or you may be able to get a bolt in the sides, but I doubt it. Most likely you'll have to get a larger bolt and then cut it down with a Dremel tool or a hacksaw, and you'd be able to make it fit. It's very important to mention, if you are going to substitute bolts, these are blind holes. What that means is there's no exit point on the other side. So they're a certain depth, and once you get past a certain depth, you're not going to be able to put that bolt in there any further. So you definitely want to make sure that those bolts are the right size for these holes. Take your key cylinder assembly. Now make sure that the harness, see how it has a screw here? There's a screw hole here. Only goes on one way. Take it, insert it like this, and then it'll pop in place. If it doesn't line up, it won't fit flush, so there's no way to put this in wrong. Remember, the screws with the rounded heads go at the rear of the switch. Okay, and remember, the screw with the hex head goes with the connector right here. Start by just reconnecting the wires here. This goes to the fuse box where we tested earlier, the other end of this harness. Make sure the tab is facing up, and just pushing it until it snaps. As you can see, it's pretty firm, but just make sure you hear that snap, hear that click. That means it's not going to come out. This is the interlock assembly. The solenoid on that LED lets you know where your cylinder is. Bring the cylinder back up to its home position.
Now, in order to get the cylinder to line up properly, you want that outer alignment hole to line up with the hole at the bottom of the steering column. Now, press up on the cylinder assembly. If you got that outer alignment hole in there properly, you shouldn't be able to move it front to back or left to right.
Once you're locked in place, get your bracket here, place it over the top of the steering column, install my shear bolts loosely. Just snug them up so that the key cylinder stays in place. It doesn't go sliding all over the place. It's very important to check the steering wheel for proper operation before you tighten these shear bolts, because that is the point of no return. Just going to get an 8mm socket and extension. Just snug those down. I do not want to shear them. It's very important that you don't shear them. Okay. Now what I'm going to do is check for proper operation of the steering wheel. Now, how to do this is, before tightening down the shear bolts, turn the steering wheel until it locks. And make sure that it does lock. If it doesn't lock, then you haven't aligned the cylinder correctly. But if you did it the way I told you to, you should have no problems. The cylinder locks easily. Then insert the key, turn it to the 1 position. Move the steering wheel slightly off the lock so pressure is released, because it's very difficult to turn the key if the steering wheel is bearing against it. And it releases. I'm just going to take my ratchet, 8mm socket on it. I'm just going to tighten the bolt. Continue tightening until the head just comes right off. Going to go off, get off this one, then tighten the other one. Just try to tighten them evenly. And there it is. I can feel it shearing. Oh, almost gone. There it is. Came right off. Put that away. That's garbage. Continue tightening the other side until it does the same thing. You'll feel it. It'll suddenly, instead of becoming tighter, it'll just loosen up, and then it'll just be an initial rotation, and it'll just come right off. There it is. Oh, there that goes. There they are. They're back, and those heads came right off. Now we're just going to reconnect our harnesses down there. Snap that in. Windshield wiper. Now we're just going to take our harness that we disconnected earlier to test the ignition switch, reconnect it to its spot in the fuse box, reinstall your fuse box cover.
Put your steering column cover back on, snap the top and bottom together, and install the screws.
Reconnect the negative battery terminal. It may spark a bit when you put it back on the battery. Don't be startled. Occasionally. Now here's a trick. You never want to over tighten these connectors. Just snug up the nut until you grab the connector, you can't rotate it back and forth anymore. That's enough. You're done. What happens when you over tighten is you slowly start crushing the connector inward. And once these two halves touch each other, no matter how much you tighten, it's never going to get tighter. It's just going to be loose. You're going to have to replace the whole terminal. And that can be a pain in the butt, especially if there's not that much length left on your wires from the factory. After all that, you have liftoff. That's pretty much all you need to get the job done. You know how to test the ignition switch for continuity, how to remove it, including removing those stubborn shear bolts very easily, and how to replace it and align the cylinder assembly properly. Later.